A 25 kilogram sign is supposed to hang from a pair of wires attached to the wall and a support beam, as shown in the diagram. The wires that will be used can withstand a force of tension up to 300 newtons each. Determine the tension on wire 1 and wire 2 and explain any concerns that you may have. Okay, so let's start with the free body diagram of this sign. We have the sign. Okay, we have the force of tension from wire 2, and we have the force of tension from wire 1. Now, this angle right here is 40 degrees. How do I know that from this diagram? Those are alternate interior. So I can put this on my diagram to be 40 degrees there. Okay, I'm also going to have force of gravity, which is going to be directly down. Okay, the sign needs to hang without moving or falling, so we know that the net force must be 0. We know that F net has to equal 0 because it's just hanging there, not accelerating. When several forces act on each other, the result is 0 net force. So that's what we're going to use to solve this problem. Okay, so next we're going to set up a triangle here. Force of tension 1, this guy right here, is pulling up and to the right. So you can think of it, if we could break that into its components. We have force of tension 1 is really made up of an x component and a y component. Okay, we should be kind of getting used to this. So we could call this the force of tension 1 in the x direction, the force of tension of wire 1 in the y direction. Right. We also know that in the y direction, this y direction here, the only other thing in the y direction is the force of gravity. Because we know that the net force is 0, we know everything in the x and everything in the y is going to add to be 0, right? We have no y in this part, we just have x. So because of this fact, we can figure out what Ft1y is. Okay, so first of all, I'm going to figure out the force of gravity. What is this force of gravity? And we can figure that out. Force of gravity is equal to the mass times acceleration due to gravity. Okay, our given mass was 25 kilograms. That came from our question. Acceleration due to gravity is a constant. That constant is always, always, always found on your formula sheet. Let's see if I can find it now that I said it was. I think I have to do it like this. Look at this. Acceleration due to gravity is 9.8 meters per second. It is in the downward direction, so we're going to put that as negative. I actually do 9.80, didn't they? Meters per second squared. My unit is a kilogram meter per second squared, also known as a Newton. And we get negative 245 when I multiply these out. Makes sense because that's just about 10 times 25. Okay, so we get negative 245. Let's change that to newtons because they're the same thing. Okay, now because F net equals 0, that's what I keep saying over here, F net in the y direction we know is going to be the force of gravity plus the force of tension from wire 1 in the y direction. We know this is 0, force of gravity, we just calculated to be negative 245 newtons plus Ft1y, the force of tension from wire 1 in the y direction. Well, guess what? We can solve for Ft1y. We add 245 to both sides, 245 newtons. So I found my force of tension in the y direction. Okay, so I basically have this diagram and now I know this value. So let's change that to be 245 newtons. Okay. I just did some erasing there to make it look a little better. Okay, so can I now find anything else? We know this is 40. I bet I could find this force here. Okay, so I'm looking for opposite and hypotenuse. Opposite and hypotenuse, I'm going to use sine. So sine of 40 equals opposite, 245 newtons, over the force of tension 1. Okay. Why am I finding this? Because the question said determine the tension on wire 1. So that is why I am doing this question, because I needed to know that force. Okay. So we want to get Ft1 by itself. Ft1. So I multiply both sides by Ft1, I divide both sides by sine 40. Now I have calculator work. Oh, I want to put Tt1. Force of tension from wire 1. 245 divided by the sine of 40. I got 381.15 newtons. Okay, right away we should be a little concerned. The wires can withstand a force of tension up to 300 newtons. This one has 381. We might be in trouble. Okay. Now let's look at the force of tension of the second wire. Well, it needs to, Fnet needs to be 0, so this needs to be equal to the y component of this triangle. It needs to equal this value right here. Okay, so if we calculated Ft1x, then we would know what the force of tension of number 2 is. And that's what we're going to do here. Okay, so if I wanted to know this direction right here, what I could use is I could use a couple different things. I now have this to be 381.15 right there, so I could use opposite over adjacent. I could also use cos, adjacent over hypotenuse. Either way, sorry, tangent is opposite over adjacent. I think I want to use tangent because then I'm not using something I've already calculated. Yes, that is what I'm going to do. I'm just going to write this 381 in here because we found it. Okay. Whenever we don't need to use a calculation, we always prefer to use something that we've been given, if we can. But I mean, we did calculate this 245. So, okay. So, tangent of 40. Soka toe opposite, 245 newtons over adjacent, the force of tension 1 in the x direction. I don't know if you guys are hearing that phone ringing, but I had to go answer. Okay, so let's get Ft1x. So we're multiplying Ft1x, the force of tension in 1, of wire 1 in the x direction. We multiply both sides by that. We divide both sides by the tan of 40. Okay. Force of tension, 245 divided by tan of 40. I got 291.98 newtons. Okay. What we know, F net has to be 0. In the x direction, the only two forces I have are the force of tension wire 2 and the force of tension from wire 1, only the x component part, only this part. So F net is going to equal to force of tension 2 plus the force of tension from 1 in the x direction. F net we said is 0. We don't know what FT2 is, but we know that the force of tension in 1 is 291.98 newtons. To get this by itself, we're going to subtract from both sides. So we get negative 291.98 newtons. Okay. The last thing that I have to do is, now that I've done all my work, I need to round to the correct number of significant digits. So, looks like from our problem, we could have a grand total of 2. Yeah, we had 3 here, but we used this to find our first force. So we can have 2 significant figures or significant digits. So, force of T1, 2, so we're going to put 3.8 times 10 to the 2 newtons. Okay, and force of tension 2 we found was negative 2.9 times 10 to the 2 newtons. Okay, any concerns? Yes, this should be concerning. Since the tension in wire 1 is greater than 300, force of tension in wire 1 is greater than 300 newtons, it will need to be replaced by a stronger wire. Let's put because force of tension in 1 is more than 300. It will need to be replaced by a stronger wire.